to me, taking some of the brightest minds in the world, working together and sharing resources between countries, there are very few problems that cannot be solved and there are very few things that cannot be done. My name is David Widén. I am leading the Engineering Information Management Group here at CERN. CERN is the European Organization for Nuclear Research and is the largest research organization for particle physics in the world.
So at CERN we try to figure out how the universe was born, what really happened in these first milliseconds. And to do that we are smashing together photons at the speed of light to see what kind of new particles we can create.
What we really do is that we design, we build, we operate and maintain large scientific instruments that we call particle accelerators. Over the years we have been building more and more powerful particle accelerators. In many cases we have to invent new technologies, and many of those technologies can then be used in other domains, like in medical imaging or for cancer treatment or for things like the World Wide Web, which was invented here in 1989. It's very important to stress that nothing of this would be possible without the tremendous amount of technical and engineering work carried out at CERN. The Large Hadron Collider is the largest accelerator we have at CERN. It's installed in a 27-kilometer circular tunnel, about 100 meters below ground, and it's consisted of something like 100 million components, and is often said to be the largest and most complex machine ever built by mankind. We have been using Hexagon technology for more than 30 years, and we use it in literally every phase of our projects. Starting in the design phase, where we use CAD tools like BricsCAD, and then in the manufacturing phase, we have to validate some of our manufactured components with tools like the Infinity CMM from Hexagon. In the assembly and installation phases, we use a whole palette of different metrology tools from Hexagon. And then, once installed, we often compare the as installed but as designed using laser scanners to scan point clouds and compare. And throughout the whole process we use Hexagon Enterprise Asset Management to manage our assets and follow up the physical assets.
CERN is like a big city. We have got equipment installed all around the 27-kilometer ring and even in different countries. On top of that, we have different equipment groups doing things, but they all use Hexagon technology to put this information into the same database. All of this information in a centralized place is really key for operating the technical infrastructure.
We manage an inventory of 3.2 million individually traced equipment pieces. We gather significant amount of information for our equipment. For example, the registration of 350,000 work orders a year, more than 1 million checklist items per year. Hexagon helps us by providing a system that enables us to maintain virtually every piece of equipment at CERN. By helping our users take the most out of their equipment, we minimize the downtime and maximize the overall performance of CERN facilities. So for example, one of our clients is the facility management team. Thanks to Hexagon's technology, they saving around 10-20 minutes per intervention. However, multiplied by 1,000 over a year results in significant savings.
Just the technical infrastructure of CERN is generating something like 3.5 terabytes of data every day. We are really trying to link all the information we have into what we call a digital thread of equipment data and engineering data. We are making the data more usable because we can build digital twins where we can do visualization and navigation in data in a much easier way than we could do before. We are also now carrying out a feasibility study of building an even bigger and more powerful particle accelerator, which will be more than 3 times as big as the current accelerator. Going forward, we have to make sure that we can simulate and optimize things in the digital reality before we go into the real physical equipment. The work we are doing now with Hexagon is really helping us to prepare for those future challenges, and we can then really start exploring the remaining mysteries of the universe.